Hello everyone, and welcome to this video on the Python programming language and machine learning. So in this video I will attempt to make a diverse stock portfolio using k-means clustering. Now, stock diversification is a management strategy that puts different stocks in one portfolio. The thought behind stock diversification is that different types of stocks will give a higher return and suggests that investors will face lower risks. So stock diversification is a key step for constructing portfolios. Now, as an investor, you could pick assets from different sectors, but we will make an attempt to apply a more data-driven solution by using a clustering algorithm called the k-means clustering algorithm to identify different stock clusters. So before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button. And to be notified about new videos from this channel, hit that bell notification. And the material in this video is purely educational and should not be taken as professional investment advice, as I am not a financial advisor. So please make sure that you do your research before making any sort of investment. Okay, so I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So let's get started writing this code by clicking on File, then clicking on New Notebook, and a new tab open up for you, and then eventually a new cell. And in this cell, I'm going to put in some comments. I'm going to put in a description about the program. So I'm just going to type here stock market clustering with k-means using Python. Okay, next I'm going to create a new cell by clicking that code button in the top left, and here I'm going to import the Python libraries. So I'm going to import Pandas as PD. I'm going to import NumPy as NP, and then from sklearn.cluster I'm going to import k-means. Okay, and I'm going to import matplotlib.pyplot as PLT, and then I'm going to give the plot a style. So I'm going to type plt.style.use, and I'm going to use the 538 style. All right, now I'm going to run this cell by clicking this button here to the left to check to see if I made any errors. All right, so I didn't. Let's go ahead and create a new cell, and now I want to load the data. So from google.colab, I'm going to import files, and then I'm going to type files.upload to upload the file. So let's click on choose files, and I'm going to upload this nasdaq.csv file. So this file contains information on stocks closing prices within the NASDAQ, and we're going to give this just a little bit more time to finish uploading. Okay, so it looks like it's about done, and it is done. So let's create a new cell, and let's take a look at the data. So first I'm going to read in the data. So I'm going to create a variable called df and set it equal to pd.read_csv, and I'm going to input the name of that file, which is nasdaq.csv, and then I'm going to show the data. So I'm just going to type df here, and let's run this. Okay, so now we can see this data set, and we can see our stock symbols up top. So we can see like Google, we can see Amazon, we can see Apple, and I think you kind of get the idea here. All right, so we can see all of these companies, and again, these prices here, or the prices on each of these rows, are the close prices for each of these stock symbols. All right, so let's go back over here and let's take a look at this date column. So we can see that we have data from 1/2/2013 all the way to 6/25/2021, and this gives us 2,136 rows of data and 103 columns. But we're going to make this 102 columns because we're going to get rid of that date column. So let's go ahead and do that now. So I'm going to remove, I'll make that a capital R, remove the date column. So to do that, I'm just going to type df.drop and then input the name of the column that I want to drop, which is called date. And I want it to be on the axis equal to 1. So that's the column. and then I want to remove this from within the data set. So I'm just going to put in place equal to true. Okay, and now if I run this again, we can see that the date column has been removed, and now we have 102 columns in this data set. Okay, so let's create a new cell, and now I want to calculate the annual mean returns and variances. All right, so I'm going to create a variable called daily underscore returns, and I'm going to set this equal to df.pct underscore change. And then I'm going to create a variable called annual underscore mean underscore returns. And I'm going to set this equal to daily underscore returns dot mean. All right, and I want it to be annually, so I'm going to multiply this by 252, or maybe you would want to multiply it by 253. So there's about 252 or 253 trading days within the year. All right, and next let's go ahead and get the annual return variance. So I'm going to create a variable called annual underscore return underscore variance, and I'm going to set this equal to daily underscore returns dot var, and I'm going to multiply this by 252 as well. So let's go ahead and run this cell, and let's create a new one. Okay, so now I want to create a new Pandas data frame with a column called stock symbol. So let's just put that here, create a new data frame. All right, so I'm going to call this df2 and set it equal to pd.data frame, and we're going to input the name of the columns from the data set. So that's going to be the data, and I'm going to create a column called stock underscore symbol, or maybe I'll put an S here, stock underscore symbols. Okay, and then I'm going to add two more columns. So just type df2, and the first column will contain the variances. So I'm going to call this column variances, and we'll set it equal to the annual underscore return underscore variance dot values. And then I'm going to create another column called df2, and we'll call this this column returns. All right, so we have our column returns, and it's going to contain the annual mean returns dot values. Okay, then I want to show the data. So I'm just going to type df2 here, and let's take a look at this newly formed data set. Okay, so we can see the stock symbols in this column here. We can see the variances for each of those stocks here, and then the returns for each of those stocks here in this column. All right, so it looks really good. Let's go ahead and create a new cell. All right, so now in this cell, I plan on using the elbow method to determine the number of clusters to use to group the stocks. So let me just put that in comments here. I'm going to put use the elbow method to determine the number of clusters to use to group the stocks. Okay, so in cluster analysis, the elbow method is a heuristic used in determining the number of clusters in a data set, and this is according to Wikipedia. Also, according to Wikipedia, the idea of the elbow or knee of a curve is to be a cutoff point for determining the number of clusters to use. In mathematical terms, it is a point where diminishing returns are no longer worth the additional cost. And in clustering, this means one should choose a number of clusters such that adding another cluster doesn't give much better modeling of the data. Okay, so let's first get let's get and store the annual returns and annual variances. All right, so I'm going to create a variable called x, and I'm going to set this equal to df2, and again I want to get the returns and the variances. Okay, dot values. All right, next I'm going to create a list to store the k-means inertia. So I'm going to call this inertia underscore list, and I'm going to set this equal to an empty list for now. And then I want to loop through 2 to 16 clusters to find the best number of clusters to use. So for k in range 2 to 16, I'm going to create and train the model. So I'm just going to type k-means. I'm going to create a variable called k-means. I'm going to set this equal to k-means, and then I need to give this the number of clusters. So n underscore clusters will be equal to k, and then I need to train it. So just type k-means dot fit, and we're going to input the data, which is x. And then I want to append k-means inertia to the list. So we have our inertia list, inertia, there we go, underscore list, and I must be misspelling it here. So let's see, inertia. I'm just going to come up here. I'm going to highlight this. There we go. So I'm spelling it correctly now. I can see that. All right. So I'm going to do inertia list dot append, and I'm going to append k-means dot inertia. There we go. And then underscore. All right. So k-means inertia uses sum squared error, also known as sum of squares or sum of squared residuals. Okay, so that's what k-means dot inertia underscore uses for errors. All right, so now that we have that, I think we're good. So let's go ahead and plot the data. All right, okay, so to do that, just type plt dot plot, and we're going to plot the range from 2 to 16, and then we're going to plot that inertia list. So that's inertia underscore list, and I'm just going to come up here. I'm going to highlight this and copy it using Control C, then come here and paste it using Control V, just to make sure I'm spelling it correctly. And then I'm going to give this plot a title. So I'm going to type plt dot title, and I'm going to call this elbow curve. And then let's give the x-axis a label. So type plt dot x label, and then we're going to input the number of clusters. And then I want to give the y-axis a label. So I'm going to type plt dot y label, and it will be inertia or sum squared error, or SSE for short. Okay, and then I want to show the plot. So I'm going to type plt dot show, and let's run this. Okay, so there we go. So now we have this nice plot, and now you can get an idea of why they call this the elbow method. So it looks like there's an elbow in the elbow curve here, and this is exactly where we will find the number of clusters that we will be using for this. So I'm going to use the number 4 here. So I'm going to use 4 clusters for this project. So let's go ahead and create a new cell. And now I'm going to get and show the labels or groups for each stock in our data set. So let's create k-means again, and let's set this equal to k-means, and then let's give it the 4 clusters. So the number of clusters will equal 4, and then let's train this as well. So put dot fit, and we're going to input the x data set, and then we'll create a variable called labels, and I'm going to set this equal to k-means dot labels underscore, and let's show labels. All right, so let's run this. Okay, and now we can see our labels. So we have 0 to 3. So we have 4 different labels in total. So now let's add these labels to our data set. So let's create a variable. Let's create a column called cluster underscore labels and set this equal to labels. And then let's show the data set. So just type df2 here and let's run this. Okay, so now we can see our data set. So we can see the stock symbol and the cluster that it's associated with, and of course the variances and the returns. So it looks really good. So we're on our way. Let's go ahead and create a new cell now. And I want to plot and show the different clusters. So I just want to show it visually. So to do that, just type plt.scatter, and then we're going to input data from our x variable. So I want all of the rows from that data set from column 0. That's the first column. And then I'm going to do the same thing, but for the second column. So that's at position 1. All right, and then I'm going to set c equal to labels, and I'm going to set cmap equal to rainbow. All right, and then let's give this a title. So just type plt.title. I'm going to call this k-means plot, and let's give the x-axis a label. So plt.x label will be returns, and then let's give the y-axis a label. So type plt.y label, and it will be variances. And then let's show this plot. So plt.show, and now let's run this. Okay, and now we can see our clusters visually. So pretty cool, huh? All right, so let's go ahead and create a new cell, and now I'm going to create a function to build a simple diverse portfolio. All right, so let's call this function, let's call it diverse underscore port. So for I in range 0 to 4, I'm going to create a variable called symbol, and I'm going to set it equal to df2, where df2 cluster label, cluster underscore label, or maybe it's labels within s, where that equals I. And then I only want the first row of data. Okay, and then I want to print this. So I'm going to print symbol, and actually I want the stock symbol. So stock symbol, maybe that stock symbols within S, and the cluster labels, cluster underscore labels. All right, so that's what I want to see. So let's go ahead and run this. And I definitely misspelled something here. Let's see, is it latest label? So let's just highlight this, copy using Control C. So I'm copied it using Control C. Let's go down here and let's, there we go, right here. I just need my bracket, I think. So let's run this again. All right, so everything's good. Let's create a new cell, and now let's run this function. So I'm just gonna come up here, highlight it, and copy it using Control C, and then come down here and paste it using Control V, and I'm gonna run this. Okay, and now we can see a very simple yet diverse portfolio. Okay, so we are done placing these companies or stocks into different groups, which allowed us to create a diverse portfolio. But remember that we didn't remove any outliers in the data. We didn't do any data analysis to determine good stocks to invest in, and we used a heuristic to determine the number of groups as opposed to finding the optimum number of clusters. So this program isn't perfect, but I hope that you all enjoyed it. Well, that's the end of the video. If you want to start an investment portfolio of your own, then you can click on the link below in the description, and get 2 free stocks valued up to $1,850 on Webull when you deposit $100 or more on their platform by using that link. And if you would like to support this channel or just get the code and dataset, then I will leave a link to my Patreon page for that as well in the description below. Thanks for watching, and I hope you all have a wonderful, fantastic day, and I'll see you in the next video.